Hey everyone, I'm really sorry I had to cancel the session today on the very last minute because at exactly 4 p.m. the fire alarm in my building went off and I had to leave the building and I knew I wouldn't come back in time, so I just canceled the session. But as promised, I'm going to make a recorded session for you all and upload it so you can see it. It won't be as interactive as I had planned it to be, but trying to do the best of the situation now. In today's session, I had planned to go over periodic table, which is Module 3, Part 3 in the Canvas slides. Um, yeah, and there's a Kahoot quiz I made for you guys. I make a link to that quiz in the announcement page, and I'll try to put it in the description as well. But if you have any questions, feel free to email me always, and I can help you over there. But starting with the session, before we move on to the actual material, I want to review a few things first. Um, let's review things before Module 3, Part 3, like in Part 2. You learned about parts of an atom, atomic number, and atomic mass. And I want to make sure it's like very clear to you also. I have three questions for you guys. I want you to listen to the question, think over it, pause the video, write the answer, and then come back to it. Okay, do not just keep watching the video for the answers. If you want to memorize things very well and have good recall in the exams, I recommend you writing the answers on your own first by pausing the video and then checking your answers with my answers. Okay. So my questions for you guys is, what are the three parts of an atom you learned? How do you calculate the atomic number? And how do you calculate the atomic mass? Okay, that's all I'm asking for you. So pause the video over here, think over these questions, write them down in a book or something, and then replay the video and then check your answer if they match with mine. Okay. Okay, so hopefully you guys wrote the answers down. And so the answers to this question is the three parts of an atom are first an electron, the order does not matter, then a proton, and then neutrons. Awesome. Um, I have a follow-up question with this one. Can you tell me the charges present on these three particles and which of them have significant amount of mass on them so that they can contribute to the mass of the atom? Okay, so pause the video here. Think about these two questions. What are the charges on each of these particles and which of them have significant mass so that they can actually contribute to the mass of the atom? Pause the video here, think about it, write it down, and then come back. Okay. Hopefully you guys wrote electrons have negative charge, protons have positive charge, and neutrons have no charge. Okay. And for the question about the mass, the answer is the proton and the neutron contain significant amount of mass on them to contribute to the mass of the atom. Okay. Each of them have one atomic mass units worth of mass on them. Electrons also possess mass. They have some weight, but it is so small and is negligible that we don't count that weight into the weight of the atom because it doesn't really contribute anything. Okay. Okay. So that's for question one. Question two: how do you calculate the atomic number? I hope you guys wrote atomic number is the number of protons in an atom, right? One can also say that because an atom is neutrally charged and proton is positive charge, you must also have equal number of electrons in the atom to have a neutral charge, right? And that's absolutely correct. But then you can ask me that can I say the atomic number of an element is equal to number of electrons? I would say no, for this reason. Okay, let's take an example of nitrogen. Nitrogen has 7 protons, 7 electrons, and 7 neutrons, right? So you would say that because there are 7 protons, the atomic number should be 7, right? That's correct. Also, we write atomic number on the upper right side, ah, upper left side, my bad. On the upper left side of the atom. Okay, I was saying the atomic number should be 7 because number of protons is 7, right? But one can also say that number of electrons is also 7. So why can't we say the logic is this is 7 because this is 7? The reason for that is because in different conditions, nitrogen can gain or lose electrons. So maybe you can find an atom of nitrogen who only has 5 electrons, or 6 electrons, or 8 electrons. But is it still nitrogen? Yes, it is still nitrogen, but the number of electrons are variable, and we want the atomic number to be like a constant characteristic number for the element, right? So we cannot really consider the number of electrons to be the atomic number. But at any given condition, any given point in time, the number of protons always remains constant in nitrogen. So the number of protons becomes kind of like a defining number for the species. Okay, if I take out one proton from nitrogen, I have 6 protons left. That makes it a carbon atom. I've completely changed the species of the atom. If I give one proton to it from 7 to 8, it becomes oxygen. I've again changed the species. So by changing the number of protons, I change the species of the atom and the characteristics completely. However, if I take or give electrons, all I do is take or give charge from the atom, as you see like in further lectures, but does not change the species of it. Okay, so you cannot really call atomic number to be the number of electrons because that's variable. Number of protons though, that's pretty constant. That's always constant. So that's what atomic number is. Yeah, and then for the next question, atomic mass. Uh, when you answer question one's follow-up question, which of the particles possess significant mass, we say protons and neutrons have significant amount of mass in them. So to calculate atomic mass number, all we do is we take number of protons and we add number of neutrons to it. Okay. So back to this question, back to the example of nitrogen. I'm gonna clean up a little. We had 7 electrons, 7 protons, and 7 neutrons. So how do you calculate the atomic mass? It's simple. You take 7 and you add 7. That makes it 14. Okay, we write atomic mass numbers on the lower left side of the atom. So now we have nitrogen, whose atomic number is 7, which is always 7, doesn't ever change, and the atomic mass is 14. So I have a follow-up question for this. Okay, think about it. If we give and take protons, we change the species. We just said that. If I give and take electrons, nothing happens to the species, but the charge changes. What happens if I give or take neutrons? Okay, pause the video, think about it, write it down, and then come back to the video. The question is, what happens if you give or take neutrons? Okay, so let's take another example. Same as nitrogen, 7 protons, 7 electrons, but now I added a neutron, make it 8 neutrons. My atomic number is still 7 because protons is still 7. However, my atomic mass is now 7 plus 8, which is 15. So my question to you is, have I changed the species? No. Have I changed the charge? No. Have I changed the weight? Yes. And that's all I've changed, right? So the question again, what would this pair of nitrogen atoms be called? There's one specific word, starts with the letter I. Pause the video, think about it, go through your notes, write it down and come back and tell me what is the one name which you use to describe a pair like this where it's the same species but different atomic masses. Okay, hopefully you get it back. The answer for this is isotopes. Again, this was in module 2 part 2, module 3 part 3. Isotopes are a pair of atoms, or not just a pair, a group of atoms whose atomic number is the same, so the same species, but they have different atomic mass units, different atomic weights. That means the only changing factor is number of neutrons, and number of neutrons almost never affect the properties of an atom. So you consider practically the same thing. Okay, the way I remember this concept is, I think of my friends. Some of my friends are pretty skinny, but some are pretty fat, pretty chubby. But in the end, we all like still humans, right? We're same species. But the only thing which has changed is our weight, our masses, our weights. And so your friends and you can be considered as isotopes if you have different weights. Awesome. Okay. If you have any questions on this, feel free to always email me. My email ID is DAKGHONE@iOS8. I'll try to answer your question over emails as soon as possible. But okay, moving on to today's actual material, groups and periods. Groups and periods are part of the periodic table. And so what's a periodic table? Periodic table is basically an arrangement of the elements. And so my question to you now is, are the elements arranged alphabetically by atomic number or atomic mass? Okay, so pause the video, think over it, and then tell me if the elements are in like by what criteria are the elements arranged. Okay, so if you're back, if you look closely, the elements are arranged by the atomic number, increasing atomic numbers from left to right. So on the left side, we have hydrogen, whose number is 1. On the right, we have 2, helium. And then we go lithium 3, beryllium 4, boron 5, and so on. And then we keep going left to right, the number increases. The mass looks like it increases, but that's not what we're looking for. The criteria is increasing atomic number. Okay. So now my question for you is, what are groups and what are periods? I'll give you a hint. These are names for either vertical or horizontal arrangement of elements. So like this is an horizontal arrangement, not just like the entire line is a horizontal arrangement of elements, while this is a vertical arrangement. So which of these is a group and which of these is a period? So pause the video, think over it, write it down, and then replay the video. Okay, so if you're back, and if you said that groups are vertical arrangements, that's exactly right. And so that makes period the horizontal arrangements. Okay. Why this is very important is because something you might have seen in the slides is a group of elements, that's a vertical set of elements, possesses very similar properties. Let me show you an example real quick. Let me erase this so it's a bit cleaner. I don't know if you guys are taking the lab, but in some chemistry labs, they'll show you that lithium, sodium, and potassium, they all look very similar. They're very soft. And if you ever come in contact, if you ever bring those 3 elements in contact with water, they always explode violently, like create a lot of heat and energy. So that's a very similar properties of theirs, right? And so all the elements in a group, in a given group, have very identical or similar properties. For that reason, groups are also called as families, not officially, but like I like to call them families sometimes. Like I call this a lithium family. I would call this the oxygen family because they possess similar properties, even though they're bigger in size, properties are similar. Why are periods important? Periods are important because as you go left to right, you have some atomic trends you will see in the coming lecture. So you can also define a few trends based on a period, right? And so then my next question for you guys is, once you know what are groups and periods, we have some names for certain groups, and the names are given on the left side, on the right side. So I want you to pause the video, think of these 5 group names, and then place them in the right spots on the table, like which groups are called alkaline earth metals, which group is called halogens, which group is called alkali metals. So pause the video, think over it, write it down, do not cheat, and then replay the video and I'll tell you what the answers are. Okay, so if you guys are done with it, I'm gonna move ahead. Alkali metals are the one in group 1A. Okay, alkaline earth metals are the one in group 1B or group 2, my bad. Halogens are the one in group 17. That's the fluorine group. Chalcogens are the ones in group 16, which is the oxygen group, or the oxygen family. And the noble gases are the ones on the very end in group 18, which is the helium family. And I don't know how these names came to be, but I think it's a pretty neat way of referring to like a group of elements from the given name. Yeah, I would try to learn these for maybe an exam or something. Moving on. Oh, before we move on, you might see that there are things like this name possesses the word alkali and metals, because the reason for that name is Uh, Normally, these elements, except for hydrogen, like lithium, sodium, potassium, rubidium, are found in nature as their oxides, which are alkaline, and these are also metals. And so, segueing with that, we can broadly classify all the elements in a periodic table into three categories: metals, non-metals, and metalloids. Okay, and this picture uses noble gases too. So my question for you on this slide is, can you help me identify which of them are metals, which of them are non-metals, and which of them are metalloids? They're already color coded, so just tell me if what the blue ones are, like from this list, what the yellow ones are, what the green ones are, and what the purple ones are. So pause the video, think over it, write it down if you want to, and then replay the video. Okay, so if you're back and if you're done solving this, um, the answer is the blue ones uh, is composed of hydrogen, carbon, nitrogen, oxygen, fluorine, and these are all non-metals. It's too big. Okay. Then the yellow ones consist of lithium, beryllium, aluminum. So like all these names sound super familiar, right? Aluminium, Fe is iron. So these are metals. And then the green one somewhat lie in between the metals and non-metals, are like transitioning. So they are called metalloids, and they possess properties similar to metals and non-metals. So they like the semi-metals, semi-non-metals, or metalloids, what do you call them? And we just solve this one. The last group of elements is called noble gases. Okay. The reason we have this categorization is because it's very broad, but one thing in common is all metals have similar properties, like physical properties. So do all non-metals and all metalloids. And so the next slide talks about that. One thing I want to point out over here is if you notice, all the non-metals are grouped up on the right side, except for hydrogen, because hydrogen acts like an anomaly in a lot of cases. Hydrogen is not a metal, it's a non-metal, but it has somewhat similar properties to group 1 elements. So it's put on here. You might find some periodic table where the hydrogen box is in the middle of the table because it doesn't fit and like in either side. But I think that's a pretty cool fun fact I wanted to mention there. Moving on, I want to talk about properties of metals and non-metals. So on the left side is the three headers, and on the right side I've made pairs of properties like brittle and bendable or malleable, like opposite things in a category: conductor, non-conductor of heat, electricity. And so my question for you is, can you help me sort the properties on the right side into the right category on the left side? So pause the video, think over it, write it down. I made it easy for you by giving you the options so you can actually put them down instead of like actually memorizing them. So, for the exercise, actually pause the video and do it, and then replay the video once you're done to check your answers. Okay, if you're done, I'm gonna start solving it. The reason I made like these two categories like opposites is because it'll be easy for you to remember. And the easiest way to I remember this is I think about a metal and I think about a non-metal, or I just think about a metal and a property, and the opposite is true for non-metals. So a metal I can think of um, aluminium. Aluminium is bendable and malleable. So I'm going to put this property for metals. Okay, and so the opposite of bendable is brittle. So I'm going to put that for non-metals, and that's true for almost every metal, which is a solid. That metals are soft, also they're shiny and lustrous, and you can bend them. So believe it or not, sodium is also a soft metal which you actually beat up and make like a flat sheet or like cut it with scissors. I have cut sodium with scissors and it's very satisfying. But you might not be able to cut other metals with scissors, but you can definitely like break them by folding them. On the other hand, metals do not break by non-metals do not break by folding. They break by like dropping or shattering. Okay, so they're not very bendable. Uh, think about conductor and non-conductor of heat and electricity. Again, I think about aluminium or iron, and iron conducts electricity and also conducts heat. It gets heated up real quick. It's not an insulator. It transfers heat. So I would say iron is a conductor. And so the opposite of that would be non-conductor is a metal, non-metal. Okay. Uh, for gases and solids, about the states, again, I think about a metal. Sodium is a metal, aluminum, iron, copper, zinc, platinum. These are all metals. Everything on the left side is a metal. And I always see them, almost always see them as solids. So I would say they're mostly solids. There are some metals who are liquids. Can you think of an example of a liquid metal? An example of a liquid metal is mercury. Mercury is a metal. It's shiny, but it has a very low boiling point. So it's a liquid on room temperature. But if you go cold enough, it turns solid, and then has the properties of conducting heat and like the softness and the bendability. So the opposite of solid is gases, and so non-metals are mostly gases like oxygen, nitrogen, fluorine, chlorine. These are all gases, and they're non-metals because they're on the right side of the periodic table. The last one is about low and high melting points. And a good way to remember that is things which are solid to like which look solid to you in room temperature have not melted yet. So you need to heat them up to melt. That means they possess a higher melting point and therefore even a higher boiling point. So because we said most metals are solids, they will possess high melting and boiling points because they haven't melted yet. On the other hand, the opposite, non-metals you said are mostly gases because they've already boiled off. Room temperature is too hot for them to stay solid, and so they have low melting and boiling points. If you go cold enough, the non-metals will turn into liquids and then solids, like in case of nitrogen. If you cool nitrogen enough to a very 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 cold temperature, it turns liquid nitrogen, right? Same goes for oxygen and carbon. I'm sorry, not carbon. Same goes for oxygen, and chlorine and fluorine, all gases. And like I said, mostly are gases, but carbon not a gas. So there are a few exceptions in both cases, like mercury was liquid, but it's a metal, and carbon is the non-metal, but it's solid. So there are exceptions. So but a lot of like regular trends is metals are mostly solid and non-metals are mostly gases. And so what goes in metalloids? Because the way metalloids are, because they lie on the transition like in the middle of metals and non-metals, they happen to be a little of both. And believe it or not, the fact that they are little of both, scientists take advantage of that. And by changing the conditions and fine tuning it, you can make a metalloid act like a metal or a non-metal. And that's how transistors in electronics work. They consist silicon in them, which is the non-metal, the metalloid. And if you apply the right amount of voltage, it starts conducting heat. If you apply low enough voltage, it stops conducting heat. And so it's a conductor and a non-conductor depending on the conditions. And that's what metalloids are. Okay. And that's all I had for this session. It would have taken longer if you guys were present and we had the session and there was a Kahoot. But the Kahoot also goes over a lot of these similar things. So I try to cover the Kahoot material as well. But yeah, that's all I had for you guys. I really hope you guys had a lot of your doubts cleared with this. I hope you have more confidence in the material now since you like we've been through this practice of solving things in small sections. But if you have if you still want to do more practice, I would definitely recommend visiting the Kahoot quiz and also emailing me. You can my email is like on the SI website as well. You can ask me any questions you want or ask me for more practice problems. I can make something for you. But yeah, my next session would be oops sorry would be on Thursday at 5:10, and I really hope the fire alarm does not go off this time. But on Thursday, I'll try to cover things from Module 3, Part 4, which is the last part of the module. I think it talks about ions, and after that, after that's over, I think you have an exam coming up. So I'll try to hold an exam review for you guys, where we go over everything we've learned like till date, so you have a good exam. Okay. Hope to see you guys on Thursday in my next session. Until then, stay safe and take care of yourselves.